So welcome everybody, great to see a full room. This is super exciting. Thank you for spending your Saturday here at the University of Auckland. And this session is presented by Mechanical Engineering, which is one of the engineering departments here at the university. A quick hands-up question, who is a prospective student to become an engineer here? Good, most of you, great. So if you choose to study engineering at the University of Auckland, you're going to meet me the very first year, either in semester 1 or 2, and I teach CAD, so computer-aided design, so 3D modeling in the computer, and engineering drawing. And those are really fun and powerful tools as an engineer. So what I'm going to talk about a little bit today is what is mechanical engineering, what can you do as a mechanical engineer, and what are the job prospects as a mechanical engineer. So mechanical engineering concerns really everything that moves. The first thing you probably think about is a car, but there are lots of things that move. Even things like the little motor that vibrates inside your phone. That is a mechanical engineering problem to a big extent, to make that one work and last for the lifetime of the phone. We concern ourselves with things that have to do with energy, use and conversion of energy, and also conservation of energy, of course. And design, production, operation of all kinds of mechanical devices and systems. That is cars, medical equipment, engines, aircraft, robots, refrigerators, yachts, paper mills, and pretty much everything you can think of. I would say that mechanical engineering is one of the broadest of the engineering disciplines. You can work on pretty much any kind of area of your interest as a mechanical engineer. As soon as something moves, there will be a need for a mechanical engineer. As a mechanical engineer, you need to understand, for example, how power is transferred, how fluids flow, how objects resist force, and how objects move, and how materials behave. That sounds kind of boring if you look at just written on a paper like that, but it is quite exciting, all of that. And we ask ourselves, how can we control this? How can we design for the specific purpose? And how do we make our designs? The car is probably the most traditional mechanical engineering example. So traditional, this is what marketing department gave me for my slide. I would have maybe preferred something more exciting than the car, but it really summarizes all the aspects of mechanical engineering and all the challenges we have as engineers in the future as well. Speaking of cars, the university has its own racing team. So if you're into motorsport like I am, I will show you just that in a moment. We have a racing team. It has about 50 students in it, and they build a new car every year. So from scratch, they design everything themselves, and then build it and race it in December in Australia every year. And that's a wonderful opportunity for the students to get hands-on experience. So in my opinion, the students that have gone through the Formula team come out and they're much better engineers than the students that didn't get this opportunity. But it's not just about cars. So mechanical engineering is about anything that has these basic properties. It moves, it transmits power, it needs to resist force, and so on. And it's always, they give me these slides and they try to put really interesting things into them. But I think they miss out the whole section of things that we don't think of necessarily as mechanical engineering, but where mechanical engineers actually work. So I teach CAD. That's my profession, that's how I make my living. But I also use CAD and 3D printing as my hobby because I just think it's really, really fun. And I may not be the most girly girl, but I do like stuff like handbags, always done, that's a thing. But I've always been disappointed. I bought these expensive designer handbags, don't tell my husband how much I paid for them. But I was never happy with it. I wanted a handbag that had to fit my iPad, had to protect my iPad, and it had to have lights built in so I could find my keys when I get home at night. So I thought, I can design this myself because I'm a mechanical engineer, I can build anything I want, so I did. So I went to Inventor, which is the software I teach, And I just designed my own handbag and 3D printed it. And it has everything I want. It protects my stuff. It fits my iPad. And as a mechanical engineer, you always study some basic electronics. It has built-in lights so I can find my keys. And that's a no-brainer. It's such a simple thing. It's a battery coin cell and LED strip. And why don't all handbags have LED lights in them? That's a question I don't understand. But the fact is, if you, for example, have a great passion for fashion, there are mechanical engineers working at Chanel, Louis Vuitton, and so on. They design hinges, handles, they model handbags, they model shoes. By the way, I made my own shoes as well. These are 3D printed. These are 3D printed in rubber. I will send them around. I did step in a chocolate dessert, nothing else, okay? Sorry about the stain at the bottom, but I can't get it off. I promise, it was a dessert. So when you think mechanical engineering, don't only think cars, machines, airplanes, and things. There are pretty much anything you can think of, there will probably be a job for a mechanical engineer in that field. So, that said, this is the slide they gave me, design thinking for technological innovation. Well, I would say this instead. Studying engineering makes you a superhero. It gives you tools and skills to create anything you want, and you will create things that have never existed before, just like a superhero. Welding is one of my favorite activities. Typically not heavily emphasized in mechanical engineering, but it certainly is a specialization one can choose if you have that desire. But as part of my superhero feeling of being an engineer, I wanted to save the planet, because that's what superheroes do. So when I was in engineering school 9 years ago, I decided that I wanted to build the world's fastest electric motorcycle. I wanted to show that electric cars are really fast and really sexy. So I just decided one day, let's build something that's insanely fast. So this is my own engineering project. This is my hobby when I am working on this when I'm not teaching here. The name of this motorcycle is the Kilojoule. It is technically a motorcycle. I will send around this. I will send around two things. This is my next design, which I'm working on. It's a motorcycle because it has 3 wheels. And the official definition of a motorcycle is a vehicle that has 3 wheels or less. So this is technically a sidecar motorcycle, but a very extreme motorcycle. Philosophically, it's really a car with 3 wheels. It is the world's fastest electric motorcycle at 434 kilometers per hour. And yes, I am the driver. No one else fits in it. It's that simple. So if you're more than 5'2", sorry, you can't take it for a drive or a ride. So I said, this is the fastest electric motorcycle in the world. But how fast is really the fastest? And you can maybe understand, looking at this timeline, at 434, I'm not particularly fast. And you can also see why I find engineering so exciting, because there's so many records that can be broken. There actually is never an end of the number of records that can be broken. Anyway, on this line, I am there. I am just a tiniest bit slower than the world's fastest production car. The world's fastest production car is at 447 kilometers per hour. That's quite a bit faster than your family car. A whole lot faster than the Nissan Leaf I drive to work every day. But it's definitely fast enough for Auckland traffic. And 100 kilometers per hour was the world's fastest car in 1899. That's a speed that I'm happy if I can reach in the morning traffic here in Auckland. The world's fastest car, 1899, was battery powered. And then after that, shortly after that, internal combustion took over. And now, as you all know, electric cars are coming back again, big time. The world's fastest electric car is a whole lot faster than I am, 547 kilometers per hour, built by Ohio State University. I want to beat them, of course. That is still quite slow compared to the world's fastest car, fastest wheel-driven car, that's over 800 kilometers per hour. It has a turbine engine from a helicopter as its powertrain. The world's fastest motorcycle is over 600 kilometers per hour. So that's where I'm aiming for with my next project. That is still quite slow compared to the world's fastest car, which is actually supersonic. So it beats the speed of sound at about 1,200 kilometers per hour. That in turn, it's quite slow compared to the latest contender that's shooting for 1,000 miles per hour or 1,600 kilometers per hour. And these cars up there at the very top, they are thrust powered, so they have jet engines or rockets. So there's always more you can do, there's always faster you can go. So that's me inside my motorcycle. You can see it's tight because it is built for me, and it's also actually built mostly by me. So you know, when you're in engineering school, you have so much time to spare and money to spare. Yeah, that's of course a joke. You have basically no life outside school, really no matter what engineering degree you choose. But if you squeeze in an hour between physics assignments and maths homework, and you work on some project that you have passion for, you do that week after week, month after month, year after year, you actually end up with something quite amazing. So that's what I did. And I said it was built for me. Well, it was built mostly by me, and here are just a few images from over the years. That's my first test ride. I had the opportunity, I have a husband that's an engineer as well, quite a bit older than I am. So I had the opportunity of having a small workshop at home. So things were a little bit easier for me. But you can always start out with a smaller project. And if you really want to build stuff, you will find a way of doing so. And here at the university, we have, for example, the Unleash space. It's open to all students. So there's the headquarters, the two-car garage where this motorcycle was built. This was in Colorado, where I lived until 2 years ago, and then I came to New Zealand to teach here. So why did I dedicate a big part of my life and my whole savings account to building the world's fastest electric motorcycle? Well, I was upset that electric cars didn't seem to take off. We know they're better from an energy perspective. We don't get any pollution where we drive. We have much more independent on the energy sources. And still electric cars kind of seemed nerdy somehow. And this was way before Tesla really took off big time. So I thought, you know, if I build something that's insanely fast, that will get the gearheads interested in the electric motorcycle, or electrics in general. So that's what I wanted to do. So I wanted it to be insanely fast, and I wanted it to be sexy. No, that's not my typical racing suit, but it's a photo that's been published in a lot of magazines around the world, and that's really what I wanted to accomplish, because I wanted people to look at electric vehicles and think that this was something enviable and nothing nerdy or boring. So at 434 kilometers per hour, I am grabbing people's attention and getting them interested in electric vehicles. So that's kind of my superhero mission in life. So what is inside a motorcycle like this? So a whole powertrain and the system integration in an electric vehicle is a bit more towards mechatronics, which is one of the disciplines within the mechanical engineering department. There's mechanical and there's mechatronics. But in concept, this is really just a giant cordless drill with wheels. And as an engineer, an engineering student, you will acquire all the skills you need to kind of understand the fundamentals in a system like this. And then whenever you work on, you will just acquire those extra skills. So engineering school is really about learning all the fundamental knowledge and then learn how to learn more. Because you can't, after 4 years, you really come out with not very much of a specialization, a little bit, but whatever you go into in your profession, you will learn more, and you will keep learning all your life as an engineer. That's also why I love engineering, because I learn new stuff every week. So the kilojoule that you saw on the picture is retired after 9 years on the salt flat. So you race for speed records on salt. Salt is incredibly corrosive. and it simply has reached the age where it's starting to fall apart. So I retired it this year, and I'm building a new motorcycle. Green Envy will have over 1,000 horsepower, and the planned debut is in Australia 2020, so in March 2020. And Green Envy is the green model that you see floating around here. So this is what the current rendering looks like. The goal is to become the world's fastest motorcycle, full stop. So beating all the internal combustion vehicles, and to show that the electric vehicles aren't slow or boring. This is what it looked like a couple of months ago. So this is CAD, exactly what I teach. So you design, I love CAD. So we teach you that in the first year. I think it's just magic, because what it is, I have an idea in my head, and I just pull it out of my head, and I put it into the computer, into a 3D model. And this model has properties. It has mass, it has strength. I can see how things fit together. I can measure how strong things are, and I can do a complete design and see if I think this is going to work before I've even built it. So this is where it was a couple of months ago, and this was the status last week. So it's still a long way to go, but it's just magic seeing things you design in the computer actually become materialized in real world. And what I did, I took the computer files for this frame tube, sent them off to a company that laser cut steel tubing. They plugged that into their giant laser cutting machine. It cut all the tubes, spit them out on the other end, and then you just put it together like a giant jigsaw puzzle and weld it together. And that took just a couple, 3 days to put it together and weld it, instead of working on this for weeks or even months if you were to do it by hand. So you can follow the progress of this project online, greenenvyracing.com, and on Facebook, Instagram, on Twitter. I'm not very active on Twitter, but I do have an account. So I've talked about what I do. I talked about what I'm teaching. So in the mechanical engineering department, we have 2 specializations. We have mechanical engineering, which I represent, and we have mechatronics engineering. Mechatronics is where electronics and mechanical really interface. It's in automation, in robotics, and things that have both these components. And you will study a range of core topics. Of course, it's maths, it's physics, it's mechanics, design, and so on. And then you will, in the final year of your bachelor degree, you will do a final year project, which you get to choose what that's going to be. The career prospects for mechanical engineers and mechatronics engineers are great. There's always a huge need for these kinds of engineers. And what I particularly like with mechanical engineering, which I represent, is you can transfer a mechanical engineering degree to anywhere in the world. No matter what country you go to, a mechanical engineering degree will be recognized. People will understand what a mechanical engineer does. And also in most places you can work as a mechanical engineer without any extra certification or licensing. For example, a medical doctor. A medical doctor, of course, can work anywhere in the world. Humans are the same no matter in which country you are. But you have to get the license and certification in that country, which can be quite difficult. As a mechanical engineer, you typically don't need any kind of licensing. So I was born in Sweden, got my degree in the USA, and I came here to New Zealand, just started working. I got actually a migrant visa because mechanical engineers is an attractive profession. I got a work visa first, and then I just started working, no licensing, no extra requirements, because my degree is recognized. So mechanical engineering is for you if you enjoy science, if you like to understand how things work. You need good analytical skills. We do a lot of creative problem solving. You have to be strong in maths. I'm sorry to say that. You don't have to like maths, you have to be good at it. You don't have to like maths class, you don't have to like maths homework, but you have to do it and you have to be good at it because it's the basis for all engineering. If you're weak in math, you may want to consider trying to catch up. I actually did that. So when I started my engineering degree in the US, there was an entry test in maths that I didn't pass. So I spent the semester catching up on calculus and trigonometry and so on. And then I just sailed right through the first year after that. So that's all I really had to say about mechanical engineering. So thank you for coming, and if you have questions, we do have a couple of minutes to answer questions. Any questions? I will send around a handbag as well, by the way. I forgot. Yeah, go ahead.
So what software are you using for the CAD for the racing car?
So the question is, what CAD software do I use for my racing vehicles? It's the same as we teach here. It's Autodesk Inventor.
How much did the motorcycle cost?
Oh, the question is, how much did the motorcycle cost? The honest answer is I never calculated. I know for quite a few years my credit card bills and the paychecks were about equal every month. I would say combined of what me and my husband put in and what sponsors put in, probably close to $500,000 New Zealand dollars over 8 years. So if I hadn't done this, I would have certainly driven a Tesla or two. But it was actually worth every penny of that money spent, because it took me on a huge adventure, and I actually got this job based on this project. I'm not saying that you should spend that much money on a project, but hands-on projects really give you a leg up compared to everybody else when you apply for a job. Any other questions?
When you say you were supposed to be good at maths, what about like stats and calculus? Do we have to be good at those as well?
So the question is, I'm saying you need to be good at math. Do I need to be good at stats and calculus?
Would those also work?
Well, yes, that is part of math is calculus. So, but I think you're starting with calculus again in the first year. So, but I would say where I was really weak coming into university was trigonometry and algebra. So you really need to have that down solid. And what I did, I spent a lot of time on Khan Academy. Who knows of Khan Academy? Good. I have 1 million points on Khan Academy. I use that to prep for university study. And don't laugh at it. They do have stuff for kids, for little kids and so on, but they're really good, particularly if you know you're weak in an area. Go to Khan Academy and just build up that knowledge.
How does the University of Auckland program compare to similar program at AUT?
How does University of Auckland's program in mechanical engineering compare to AUT? I actually don't know. I haven't been in New Zealand for long enough to know much about AUT. Sorry. You should go to their open day and ask, maybe. Any there?
What's the main difference between mechanical and mechatronics engineering?
So what is the main difference between mechanical engineering and mechatronics engineering? The difference is that the mechatronics will have a much bigger component of electronics. And electronics, control systems, embedded system, and so on. Mechanical will have a greater emphasis on mechanical systems such as gears, power transfer, brakes, clutches, engines, and kind of mechanical components. But to a big extent, it shares a lot of, the two programs share a lot of the courses. And you can also choose your electives to get, if you say you want to go mechanical but you like electronics, you can choose electives to add on. I typically recommend all mechanical engineers take as many electronics classes as you can stand, because all mechanical systems these days also have electrical components.
How much practical work is in the mechanical engineering?
How much practical work is in mechanical engineering? Depends a little bit on what you mean with practical work. We have labs, we have design projects. Every year has a design project. If you go to the mechanical engineering booth down in the Unleash space, you will see the design projects we do in each year. The first year has very little practical work, and then it becomes more and more later in the in second, third, and fourth year. And your fourth year project depends completely on what kind of project you choose and what the supervisor can provide. Unfortunately, I would say in academic programs in general, we have less practical work than I wish we had. But that's kind of how the current education system works. So that's why I'm recommending that everybody find their own projects outside school, like going to a makerspace or do something home in your parents' basement or wherever you can work on something hands-on. Take that opportunity. Any more questions? No? Oh, there, sorry.
How well can you link this degree to the industrial world or the companies that's out there?
How well can you link this degree to the industrial world and the real world? Very much so. Mechanical engineering is a real life profession. And so mechanical engineer, you would typically always be popular with industry. You can't, if this is within your area of interest, you can't really go wrong.
Out of the everyone that takes engineering, how many people take mechanical?
How many of the students take mechanical? I'm trying to remember. I think we have 120-ish seats in mechanical engineering. 120, 180. Mechatronics has, I should know these numbers and I don't. Mechatronics has a smaller group, maybe about 80 students or so go into mechatronics. Combined, we have about 250 mechatronics and mechanical engineers. And you choose your discipline in the second year. So in the first year, all students are the same. Mechatronics, by the way, is one of the highest grade point averages to get into, while mechanical is about in the middle. I don't know if it's included in your package maybe, but mechatronics is always very popular. So if you want to go mechatronics, you need to work for high grades in your first year.
So do you mean that both of the subjects do the same course for the first year, totally the same?
Yeah, so for the first year, all engineering students, which is about 1,000 coming in every year, will take the very same courses.
And then by the end of the first year, do you take another exam and to see which pathway you're going to?
So the question is, how do you get into the next, how you get into your discipline? You qualify on your grade point average. So there is no entry exam, for example, to get into mechanical engineering, but there's only so many seats. So say we have 120 seats, and of everybody that applies to that program, the 120 students with the highest grades will get in. And if you are the 121st on the list, you will not get in. You may get your second choice. Okay, I think we used up the time. Thank you for all the questions. If you have more questions, feel free to come to the mechanical engineering booth. I will be there for the remainder of the afternoon.